Alright, boys and girls, welcome back to the drive-thru for a little 4-1 action brought to you by the deli. Hungry? Stop by the deli. Get you some fresh plums, cleaned for you by Mr. Euland. Okay, so this is help with your 4-1 worksheet, Form K. We are doing Form K before Form G, so don't even sweat that. Okay? Most of this I think you'll find to be pretty understandable and easy, but I am going to teach you some new stuff that's going to be really applicable for tomorrow's video, so I encourage you to take notes. Okay, this is just a review of what we did yesterday. Graph each function, plot at least 5 points. So really this is just graphing calculator practice. You could certainly do this without a graphing calculator. Okay, so we're going to type in y equals 4x squared. And first we'll graph it, just to get an idea of what our graph looks like. It looks like the vertex is at the origin, and it's a pretty steep parabola. But to help us plot 5 points, we're going to hit the second key and go to our table. Now notice, we might want to scroll down. To get our 5 points, we're going to have to go off of our graph here, but that's totally okay. 16, 4, 0, 4, 16. Those are the 5 points we're going to graph. So we will plot negative 2, comma 16, negative 1, comma 4, negative 2. 16 is going to be way up. I feel blessed. 2, comma 16. Negative 1 was 4. 1 was 4. Let's go back to, I feel like I've messed something up there. Let me go back. Negative 2, comma 16, negative 1, 4, 0, 0. Okay, so there's our 5 points, this very narrow parabola, just like that, okay? Alright, so now this is just a little bit more than what we've just done. And we'll just start with number 4, and then you can practice number 5 on your homework. But it says how, first we want to graph each function again, so we'll do that first. But then it says, how is each graph a translation of the regular graph y equals x squared? I don't want you to get confused by the function notation. You can always just think of f of x just means y, okay? All right, so once again, we'll get our graphing calculator out. Now we want x squared plus 4. Let's graph it. Hopefully, that doesn't surprise you. Hopefully you recognize that this plus 4 is going to be a vertical shift. So that indeed is going to be our translation. But we want to put our 5 points, so we've hit second graph to get to our table. These are going to be more manageable points. We got negative 2, comma 8, negative 1, comma 5, and 0, comma 4. Negative 2, comma 8, 6, 7, 8. Negative 1, comma 5, 0, comma 4, and then we had 1, comma 5, and 2, comma 8. This is symmetric to the x-axis. Okay, so our vertex is the point 0, comma 4. Our translation is a vertical shift 4 units. Okay, so that's what they're looking for in these. Do you remember what this is going to do on the inside of the parentheses? I'm going to make you do this one, but it's going to be a left shift. 3 units. Graph that, plot your points, and see if I'm right. Okay, moving on. Here's a little piece of the lecture that are actually new, and it's notes, okay? First, I want you to understand there are 2 forms of a quadratic equation. The typical form is y equals ax squared plus bx plus c. You'll recognize that possibly from the warm-up that we just did when I asked you to factor equations. Those 2 things are very related. So, for example, y equals x squared minus 7x plus 10 would be the equation in general form for a quadratic, okay? In this case, a equals 1, b equals -7, and c equals 10. And hopefully you recognize this form because you've used it to use the quadratic equation before. X equals minus b plus or minus big square root of 4ac all over 2a, or b squared minus 4ac all over 2a. Okay, so hopefully that's a form that you're comfortable with. Now we'll do vertex form, okay? Vertex form is y equals a times x minus h quantity squared plus k. Okay? Now, what you should know for this is that a cannot be 0. Okay? A cannot be 0. The point h comma k is the vertex. So that can be very useful in a different way. If we have it in this form, we can easily identify what the vertex is. And the axis of symmetry is the line x equals h. That is the axis of symmetry. Okay? So, before, well, here, let me give you an example. I'm sorry. So what you might see is something that looks like y equals 3 times x minus 2 squared plus 6, okay? Well, if you were given it to you in this form, maybe you recognize this 3 is going to make it 3 times steeper. This minus 2 is going to shift it right 2, and this plus 6 is going to shift it up 6. Well, that means our vertex is positive 2 comma positive 6. That's the tricky part about pulling out the vertex, is you got to flip the sign on this number, but you do not flip the sign on this number because it's really talking about the translation. We went right 2 up 6. That's what the translation does to our function, which is why the vertex is positive 2 comma 6. The axis of symmetry will be x equals 2. Okay, well, let's take a look. If we just scroll down a little bit, let's take a look at that graph. First of all, one of the biggest problems that we will have is we're going to screw up what x equals 2 is. X equals 2 is not a point. It is a line. Okay, it is a line where x always equals 2. So 2 comma 0 will be on that line, 2 comma 1 will be on that line, 2 comma 2, 2 comma negative 1, 2 comma negative 10. X is always 2. So the line x equals 2 is a vertical line. Okay? Now I'd like to graph the parabola on my graphing calculator. Okay, so we got to turn this bad boy back on. Hold on just a second here. So you get y equals 3 times parentheses x minus 2 squared plus 6. Graph it. Okay, now let's look at my table. We don't have a lot of points there that I can graph. 0, 18 is going to be way up. Let's go 1, 9, 2, 6, and 3, 9. So I'm going to graph this in black. 1, 9, 2, 6, 3, 9. Well, here is exactly why it's nice to have the axis of symmetry, which is this, because now we know that the points are going to be symmetric. If you remember, we had 0, 16 would be way up here. That means that 2 will also give us 16, and so our parabola is going to look like this. And notice how this red line here cuts it so it's equal on both sides, and that's why it's referred to as the axis of symmetry. Okay, hey, stay with me. I'm almost done with this video. Okay, one more question. Okay, what are the vertex, the axis of symmetry, the minimum and maximum value, the domain, and the range? First of all, if you want, you can just pop this into your graphing calculator, and we're definitely going to do that to check our answers. Okay, we really want to take advantage of our technology. We want to become great at using this. However, remember that h, k is the vertex. So in this case, this is h and that's k, because it's giving it to us in vertex form, which is nice. So the vertex is positive 4, positive 3. Just think, this went right 4, and this went up 3. Okay? The axis of symmetry is x equals h. So in this case, it's going to be x equals 4. Make sure you don't just write 4. You have to write an equation, because the axis of symmetry is a line, and this is indeed the equation of a line. Okay? The minimum or the maximum value will be the vertex, always will be, so we're going to rewrite that, but now we understand better what the vertex is. And then, in order to find the domain and the range, I think we should pop it in our graphing calculator first, and then use that to help us describe the domain and range. So once again, we have y equals, let me clear that, y equals 2 times, let's see, it's x minus 4, close them, square it, plus 3. All right, let's graph that bad boy. All right, so notice it has indeed went right 4, up 3. That's good. We have our vertex and our max and min right. Think about this line, x equals 4. Remember, that is a vertical line where x always equals 4. 4, 0, 4, 1, 4, 2, etc. Well, good. That looks like our axis of symmetry. So when it wants the domain, it wants the input values. What values am I allowed to put in for x in this problem? Well, anything I want. There's no restrictions. So I can put in anything from negative infinity to positive infinity. That's how I write that. That's my way of saying I can put in all real numbers for x in this problem. The range, so remember, the domain, you might want to make a note. That's your input, your possible input values. Your range is your possible output values. Okay, so what can I get for my output in this problem? Well, you might be thinking, I can get all real values, but I can't. That's not true. Look, nowhere on this graph does the output of the graph occur down here. Everything is here and up. So there's definitely output values way up here. So essentially, x can become really big. I'm sorry, y can become really big, but y cannot become negative. In fact, y can't be anything smaller than the vertex. So y can be 3. That's the lowest value that y can. And since y can be 3, we write that with this type of square brackets. Okay? But it can go all the way to infinity. There's no limit to how high y can get. And so, since infinity always comes with what I call a soft bracket, because you can never actually get to infinity. It's just approaching that. And there's your long video for the day. Thanks for watching. Boom!